Here we go. Should be popping up on your screen right now. Again, if you're not running 1280 by 1024, you might benefit by clicking on the sharing button in the top right corner, hitting View, and then hitting Auto Fit. Or you might not. Might make it look horrible. It all depends. You have to give it a try. Alright. Where we left off is... Let's see. Let's take a look at matrices real quick. Matrices won't take long at all, because they're four birds of the same feather, basically. We have source selectors. We have source matrices. Make that bigger so they all match. We have matrixers. And matrix mixers. And then some variations on those, which I'll show you in just a minute. But what it comes down to is source selector, source matrix, matrix router, matrix mixer, they're all the same thing, with just a few slight tweaks to what they do to make them take more or less DSP power. The most basic, source selector. 16 inputs, 1 output. You pick the input that you want to go to the output. Duh. Source matrix is still 16 inputs, but now there's 16 outputs, so every output can pick one input. Excuse me. And you can have the same, it's okay to have the same input going to multiple outputs, no big deal. But each output only gets one input. Matrix router, on the other hand, allows you to have multiple inputs to each output. Here's output number 1. If I want output number 1 to receive input signals 1, 3, and 4, I go 1, 3, 4. Thank you. Have a nice day. And they all go to output 1 at unity gain. Unity gain. And last but not least is the matrix mixer. If I want output 1 to have inputs 1, 3, and 4, I click on 1, 3, and 4, and they all go to output 1. In addition, I can modify the volume of each one from 0 dB down. So I can actually change the mixing of them. By the way, for those of you who've been made crazy by this, the way to change the volume, should I tell you? Should I tell you? Hold the Shift key down. Then you can grab it and change the volume. If you don't hold the Shift key down, you're just clicking on the mute buttons to turn them on like mute buttons. You can click and drag, by the way, and drag a whole bunch of them. The first one was on, so it was already on, so turn them off. So now if I click on this, I can turn on all these. Or I can go and turn off those. And turn off these. And turn off those. Then turn on this group, and turn on this group. Just by clicking and dragging. All kinds of fun stuff. Now this hide cursor function can become really useful, because if you watch, cut it out. See where my cursor is? My little hand thing? Okay, let's go down here. Now let's start this direction. Dang it. When I start going up, okay, what if I'm trying to get it to 8.8? Oh, my cursor's in the way. Oops. So by turning that on, come on. Okay, my computer's freaking out. There we go. If I turn that on, I can make the cursor go away while I'm adjusting it. It's one of those last-minute great ideas that I'm glad they figured out. I'm very glad they figured it out. Now, source selectors. Source matrix. Not the router, not the mixer. The two source selector things. It's really a source matrix is just a bunch of source selectors thrown together, right? The source selector and source matrix are both able to use signal names. So in other words, if I have my input signal set up over here, cut it out. Let's throw some input signals in here real quick. Big fat fingers, little bit. For those of you who don't know about the multiple rename command, prepare to say cool. All together now. Cool. Alright, so there's my signals. If I have these plugged into my source selector, normally my source selector says none, wait for it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. Okay? If I go back and turn on the use signal names function, now my source selector says none, mic 1, mic 2, mic 3, mic 4, and shows the signal name right there in the drop-down. That's what the use signal names function is for. If you're not using signal names, then you are allowed to use to create source names. Click the button to edit, type in whatever name you want to type in, you're done. So if you're not using signal names, you can use source names instead. Totally up to you, but you can't do both and you can't mix and match them. Now on the matrix router or matrix mixer, there are two variations of those. There is the fixed quantity and the variable quantity. Fixed number of inputs and outputs and variable inputs and outputs. When I go to place a matrix router, it says, do you want to do an adjustable or a fixed? If it's fixed, I have to tell it right now how many to put in there. If it's adjustable, come on, you can do it. If it's adjustable, then under properties, I can always go back later and say, make it a 9. No, you know, make it a 14. Whatever I need. Now, the temptation might be there to make them all adjustable. Small problem. 4,000 inputs. Okay, so I lied. They can only do 128. But 4,000 outputs. Okay, I lied. It only does 128 outputs. What's 128 times 128? Anybody? Anybody? How many cross points does that sucker have? This happy little matrix router I just created. How many cross points does it have? 128 times 128, carry the 7, plus 4, gives me a grand total of 16,384. 16,000 cross points. So 16,000 state variables are added to my design file to deal with this matrix router. Let me delete these. Right now there are 16,000 state variables in my design file. If I do this, wait for it. It's thinking. If I do this, how many state variables do you suppose are in my design file? 6? 16,384. Because London Architect has to reserve enough state variable handles for all of those potential state variables. So if you've got, you know, a handful of matrix mixers that are all variable, and that handful starts becoming like, 15, 20, 30 of them, that's a lot of pointless state variables, and it can get really stupid really fast and cause massive bloat to your design file. Which is why, if you right-click on a matrix mixer or a matrix router, the very bottom choice on the list is convert to fixed or convert to variable, whichever it happens to be. So if I go convert to fixed, it takes this 16,384 state variable object chops it down to 6 cross points. 3 inputs, 2 outputs. If I need to change it, I can always convert back to dynamic, then change it, then convert it back. Will those changes affect your control panel layout? Absolutely. Absolutely. See how long this has taken? Has to reserve those 16,378 state variables I don't need. Still waiting. There you go. Finally, it's in there. So don't use variable matrix routers or matrix mixers just for fun. They waste a lot of space in your design file. Remember what the 16 by 16 control panel looked like? Here's a 3 by 2. Now then, that takes care of matrices. Macrodynamics is stuff that I've created. WAMCO tuning is the stuff that I created, so we can ignore those. Working back up the list, we come to tools. Yeah, cool stuff. We already looked at the meter, but we didn't really look at it as a meter. There's also a meter trigger. Get over here. There's also a meter trigger. There's also the noise generator. Oops. Forgot the RMS meter. My bad. Noise generator. The tone generator. Why did my screen just freak out? And the audio coupler. Here's what these happy things do. First of all, let's satisfy my OCD. There we go. The meter is a meter. It's pretty straightforward. If the meter confuses you, I really don't know what I can do to help. It's a meter. That's all there is to it. The RMS meter is a meter. It just happens to read RMS value instead of... If you want to use... Oops. Where is it? There you go. If you want to use one of these analog VU meters on your control panel, please have the decency to use RMS meters, not peak reading meters, because VUs do not read peaks. The third kind of meter is a meter trigger. Meter trigger is actually designed for working with logic, because a meter trigger will turn on this little light anytime the signal is above 0. So if you want to trigger a logic function, you can link this to a logic source. If you want the logic function to happen at negative 3.27 dB, change the reference. Oops, wrong button. Change the reference to negative 3.27 dB, and now the light comes on at negative 3.27. The regular meter and the RMS meter both have the control output for use with the modulator. Makes no difference. They're both exactly the same output. RMS does not have a different output than the peak reading meter. Tone generator and noise generator. The tone generator is boring. There's really nothing to it. It's just a tone generator, for Pete's sake. You set your frequency, you set your volume, have a nice day. The noise generator, you have your choice between white noise, which is pseudo-random, non-correlated white noise, or pink, which is shaped white noise. It's EQ'd to make it sound like pink noise. You set your level, have a nice day. And last but not least, the audio coupler, which has the world's most worthless control panel, and I'll show you why. The whole point of the audio coupler is to change the name of your signals. Coming into it, I have mic 1 through mic 4. Going out, I have mic 1 through mic 4. I can go over here into properties and change mic 1 into Bob. And now the signal name changes to Bob. And change mic 2 to Steve. Mic 3 to Willie. Mic 4 to Ketchup. Plays a mean saxophone. And change all my signal names. Now the reason I say it's the world's most worthless control panel, all it does is show you what the signal name is coming in. Okay. Who cares? If I were excited about the incoming signal name, I would be using an audio coupler to change it. Obviously, I don't like the incoming signal name, so I don't know what the deal is with that control panel. Be aware that under Properties, if you're tired of wasting all this space on your control panel, you can always turn off Show Input Signal Names right here. Turn that off. And make it much smaller. Save a little room on your control panel because all you're doing is changing signal names. And this device can have up to 756 outputs. Okay, 48. And 48 outputs. Make sense, everybody? What the heck that thing does? It renames signals. Come on, I hit the delete key. There we go. Crossovers. First of all, we've got a low pass, ka-chink, a high pass, ka-chink, and a phase filter, also known as an all-pass filter, which I think is a horrible name. The low pass is one little tiny chunk of a crossover. The high pass is the other little tiny chunk of a crossover. Get back here. Between the two of them, you could build a crossover you wanted to. Under Properties, you can change the maximum slope on your low pass, 24 dB or 48 dB. It takes more DSP power to do 48. Same on your high pass, 24 or 48, your choice. And that affects which filters are available to you. For instance, I've got a 12 and a 24 dB per octave Linkwitz-Riley, but I do not have 36 and 48 because I'm not set to max slope of 48. If I set to max slope of 48, then ding, there's my, there's no 36. 48 dB per octave Linkwitz-Riley, then 36 is the NTM filter. I misremembered. Okay? That's really the only thing that's settable on the high and low pass filters. They're pretty boring. They do the job really well. I mean, they sound fantastic, nice and smooth, nice and clean, but they're just, they're filters. The all pass is a first order phase filter. If you don't know what first order versus second order is, then it probably won't bother you. Chances are it won't matter. The phase filter is used for tweaking phase at crossover points and such. It's actually a type of delay. We have the crossover and the stereo crossover. Crossover is a maximum of 6 bands, minimum of 1. We're going to play with the 4 band just for the heck of it. On the control panel for the crossover, it's got this groovy little display here, which shows me all of my amplitudes and my crossover points, and it shows me relatively clearly that if I want to, I can overlap crossover points. Oops. Forgot to grab the little thing. Okay, if I grab the crossover point here, these are moving together, my 4-band crossover. If I reach up here and grab just the knee, I can move the knees without moving the crossover point. For each band, I have a gain control, polarity, mute, and my high pass and low pass. High pass can be turned off, and low pass can be turned off if you don't need them. In addition, notice all these things that are appearing and disappearing over here? All these optional functions. This crossover has put me at 13.3%. If I go turn on all the options, we'll skip inserts for now, we'll come back to that. It puts me at 17.1%. So it takes a little more DSP power. But what do I get for my nickel? I get a delay per band. I get a phase control to change the phase of this band relative to the band above it. And I get a heater on my limiter. This meter on the limiter is very important because 0 on the limiter meter is your limit point. If my lows are set to plus 18 and my low mids are plus 12, my mid-range cabinet's at 3, and those wimpy little horns I bought are at negative 14 dB. Oops. Got some problems with negative numbers today. They're negative 14 dB. Then 0 on this meter is negative 14 dB, 0 on this meter is plus 3, 0 on this meter is plus 12, and 0 on this meter is 18. So I can see usable, intelligent, logical, worthwhile numbers. Otherwise, when I push my music hard enough to have the subs hit plus 18, what's the difference between negative 14 and plus 18? Anybody? About 33 dB. When you count the 0, it is. So the highs wouldn't even show up down here. See, you guys thought I couldn't hear you. I heard you making fun of my math. It's 33 if you count the 0. Really, it is. Try it. So you wouldn't see it showing up on the meter. That's why these meters show you the limit point at 0. Then they're actually useful meters. Okay? And if you turn on the insert, you have a separate input for every output band. So you can put EQs before the crossover where they belong, instead of after the crossover where they are just destructive and stupid. That's by turning on the inserts. And if you really want to, this little display up here on top, oops, clean it up. This display on the top, and I'll convert default to custom. There we go. Let's set these both to NTM 52s. This is a great illustration of what the heck the NTM filter is all about. Oh, what am I thinking? Sorry. There we go. That's what I needed. Okay, the blue curve is our NTM filters set for 200 hertz. Set for 200 hertz. You know what? Make it 500 hertz. And 4K. That's the white curve, sorry. The blue one is a high order Linkwitz-Riley set for the exact same curves. And so you can really see the difference on the display, but you can really, really see the difference if we make the display bigger. Get that out of there. Because we can cheat on what this display is showing us. Right now it's only showing us down to negative 15. We can override this turkey and go to a min of negative 60. Ooh, not far enough. Negative 90 dB. Let's try that. There we go. When we get down there, you see the lobes on the NTM filter, and you'll see how much faster the NTM rolls off down to about 67 dB, negative 67 dB. The blue is the Linkwitz-Riley, the white is the NTM. So you can see the difference in the roll-off curve. That's what the big deal is on the NTM, believe it or not, that little bit of angle there, and the fact that it's phase coherent in the crossover region. That's the big deal, though. Okay, here's your crossovers. Love them. And last but absolutely not least are the mixers and the gains and all that fun stuff. We have a gain module. We have an N input gain module. And we have an N input mixer that doesn't bother to call itself N input. A gain is a single one-channel gain. It's the simplest processing object that exists. N input gain has N channels, You have a gain for each one, plus a master and a master mute. Pretty straightforward. Your N input gain can do up to 912 channels. Okay, I lied, it's actually 32. And that's all there is to it. I mean, they're gain objects. They're kind of boring, but they do their job. Do it very well. The mixer, on the other hand, is not so boring. It's also an N input object, also capable of 912 channels, but in this case 912 means 48, not 32. The mixer maxes out at 48 channels. Why does a mixer max out at 48 channels? Anybody? 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 Because once upon a time, that was the most channels you could ever have inside one box. 32 channels of CobraNet plus 16 channels of local is 48. Now, BlueLink kind of screwed that up, but that's why it maxes out at 48. There's not much to... Oh, I've got it set for 48 channels, don't I? No wonder it takes long to make the control panel. Good grief. I'm going to put a dyslexic ferret in charge here. There's my 4-channel panel. Now, there's not much to the customization of the mixer because it's a mixer. We've got 4 groups you can turn on and 4 auxes you can turn on. And they will appear as additional outputs on the mixer as they're turned on. Turn the 4 groups on, there's those. Turn the 4 auxes on, there are those. And they'll also appear as additional controls on the control panel. Just like the pan knobs appear when you make it stereo, and they disappear when you make it mono. Here's your group controls. Here's your aux controls. Isn't this the worst button you ever saw in your life? It's actually been improved. Didn't used to have didn't have the little indicator on it before. It was just a button that said post. It's like, okay, so do I push the button to make it post? Or is it post when the button, because it was a button and you push it and it stays down? It's like, what does that mean? Which way is pre and which way is post? So at least now the light lights up when it's post. Otherwise it's pre. A couple of cool things about the mixer. It does show you the name of the incoming signal down here. It's one of a couple of processing objects that do that. The gains also do that. Input cards do that. It's kind of a cool little feature. Whatever your signal is shows up down there, and if your signal name changes, it automatically changes for you. Very convenient little metering feature. And you can also tweak the pan law on your stereo mixers. This is not very important to most people, but for the really tweaky guys out there, I'll tell you what it means. Because when you're really getting into the tweaky stuff is when you need to know about that sort of thing. If I have a signal coming into channel 4 of this console, okay, and let's declutter a bit here. There. If I have a signal coming into channel 4, and it's a 0 dB signal, and my mixer looks like this, what's the output of the left output of this mixer? What level is the left output? It's 0 dB, because I'm not modifying the gain at all. Now, if I put this straight up, now what's the output on the left output? Pan law says 4.5. So if the 0 dB input comes in the input here, the output is negative 4.5 dB left, negative 4.5 dB right, which is correct if you're summing a traditional stereo signal. Now, depending on what you're doing and how wide your stereo field is in the real world, how far apart your speakers are versus where your listeners are, it may be a situation where you're not mixing stereo signals down mono. You've got a bunch of mono signals you're trying to mix in stereo. And in that case, you might want to set the pan law to 3 or 6. If you have a very narrow field, if your speakers are very close together, like in a church, some of the long, skinny church design where the altars, everything's at the front, and the whole place is like a big, long, skinny hallway. If you're in that environment, you don't want much more than 3 dB of shift. Where if you're in a gigantic environment, you might want to shift more based on your panning. So that's why you can change the pan law. Any questions on mixers? How are you bringing up? Oh, the DSP usage right here at 3%. Just double click on it. Double click for advanced resource usage. That brings up this thing. Da-da-da. All right, what do we have left? The good stuff, right? Auto mixer. The auto mixer looks a whole lot like the mixer. It's 4 channels. You can make it up to 9,645, which is actually 48. 48 channels max. You can make it stereo. You can turn on up to 4 groups. You can turn up to 4 auxes. You can change the pan law. And then things get weird. Master slave, voice band direct. What? We'll get to that. Control panel first. There you go. We have all the standard group stuff, all the standard aux stuff we already talked about. But then we have the actual auto mixer functionality. Now the auto mixer itself has an on button, on indicator, override button, the off gain, the auto button, and this is the enter data field for the off gain. And you have the speed and the slope of the auto mixer down here. All of those controls, I'm going to explain to you quickly what they do, but if you look in the help file, there's a help file page that goes over every one of them again and explains what the heck they do. So in 6 months, a year now, when you finally get around to needing an auto mixer, you don't have to try and go, now, what did Dan say the override does? Here's everything in a nutshell. Speed affects how quickly it responds to changes in input volume. Because the way the auto mixer works is I set up a gain structure. And if one microphone is open, currently being used, then that microphone receives all that gain. And we have to try and set it up so it's just below feedback, obviously. If 2 microphones are open, they each receive 3 dB less than full gain. If 3 microphones are open and 4 microphones are open, they just share the available gain, so that your overall system gain remains the same no matter what. Okay? That's how it works. Now, auto determines whether or not this channel is part of the auto mix. If I click this on channel 4 is no longer part of the auto mix. It now works like a regular mixer channel. Off gain. When this channel is not being used, how far should I pull down the gain of this channel when nobody's listening to it? On. The on indicator actually is there for the purpose of tying it to a voice-activated camera system. And on does not really mean that it shows you which channels are on, because no channels are ever off, really. What it does show you is the last channel to turn on. In other words, if I start talking on channel 1, and while I'm talking, Bob starts talking on channel 2, and we both keep talking, and then Steve starts talking on channel 3, only channel 3's light will be on, because it was the last one to start making noise. Override. If you have set your system up properly, override will not cause feedback. If you haven't, it will. Override causes that channel to appear 12 dB hotter to the sensor channel, the sensor part of the processing object inside. So in other words, it makes it look like, to the auto mixer, makes it look like you're shouting into your microphone. If you're shouting into your microphone and Bob's speaking in a normal tone of voice, the auto mixer is going to give most of the gain to you, because that's just the way it works. So the override is intended to bump you above Bob without you having to shout. So the speed is how quickly it responds in those situations, and then the slope is how much it changes the channels to give the loud guy priority over the quiet guy. Now the other properties we have out here, the way the auto mixer works is it takes all of the input signals and combines them together into this threshold mix thing. And it uses that overall mix to compare each individual channel to it. So if you want to daisy chain 3 auto mixers and make them all act like one auto mixer, first thing you have to do is go from the first or the last slave, chain out to the chain in of the next slave. Chain out, chain in on the master. That is now fed all of those sensor values up to the first auto mixer. The first auto mixer puts them all together and forms them into the threshold signal. The threshold signal is redistributed not in a daisy chain fashion, but straight redistributed to every single auto mixer. And then you have to decide, is this going to be my single output, or am I going to take all 3 of these outputs and mix them together? If you're going to take all 3 of them and mix them together, then you're done. Nothing to worry about. If you want to use just that one single output up there, you just need to take your mix output from this one and bring it up to the mix input of this one. Mix output here, up to the mix input up here, and then this will have your master output. Very simple. You're not going to remember it, don't worry about it. It took me 2.5, 3 years to memorize that. When it comes time to do it, you can do one of 2 things. Either look it up in the help file, because the help file does explain exactly how to configure this, or you can send me an email and say, how do I do this again? Now, when would you want to do this? Pretty much the only time you'd have to do it is if you had if you needed an auto mixer which is bigger than 48 input channels. I'm not sure how to say that. A larger than 48 channel auto mixer. Because we can make this one up to 48 channels, right? Which screws up where my threshold is plugged in. You get the idea. But if you need more than 48 channels of your auto mixer, you have to daisy chain them together. That's what the master-slave status is for. Any questions on that? That one usually confuses people. Nobody's concerned, scratching your head about that one? All right, you guys nailed it. Let's move on. Last but not least, why can't I do that? Oh, can't delete those. Last but definitely not least, I'm going to open a whole different design file. Wait a minute, where is it? Harman, Blue, Training, Design Files. I'm just in dope mode today for some reason. RC2, maybe? It's either RC or RC2, we'll see. Or it could crash. Oh wait, there it goes. But wait, there's more. Yeah, not it. Should have known, I guess, wrong. Okay, room combiner. I've got a bunch of microphones, or a bunch of background music sources, going to a blue link, a bunch of microphones and aux inputs going to a blue link for 8 rooms into here, into an 8-room combining object. Now, first caveat on the room combiner. It's a room combiner. It's not a microphone combiner, it's a room combiner. If the Milford room has 6 microphones in it, you have to mix them together into one room signal before putting them into the room combiner. Why? Because it's a room combiner, not a microphone combiner. You have to get each room down to one signal. We can cheat because it could be one stereo signal. Fine. But you have to set it for either mono or stereo and live within those limitations. Okay? The room combiner does not have a built-in mixer for each room. You have to do that separately. That's what these guys are. And this down here is the background music. When you first place a room combiner, it looks like this. Little sick anemic guy, little tiny thing. It's a wee little processing object. You have to add the number of rooms you want and the number of background music channels you want. That's done right over here. Number of background music inputs, 4. I changed it to 16 up here. Number of rooms. That's done on click button to edit. We'll get to that in just a minute. First, let's go into the control panel. Here's the main control panel for the room combiner. This is actually the volume panel. Here's the combining panel. If I want rooms 1, 2, and 3 to all be in group 1, I'm currently set for group 1, so I can just go 1, 2, 3. If I want 4 and 5 to both be in group 3, click on group 3 and go 4, 5. When I go back to room controls, hey look, they're combined. They're all the same color. If I move the faders, they all move together. Cool, no? Now, let's go back here. Oh. Had to convert it first. There we go. Copy. Paste. Okay. Here's what's really going on. I want to get them all on the same page so we can stop flipping back and forth. Let's go to operate mode here. Okay. I have a mute for the sources, which is microphones basically, and a mute for background music and volume for each one of them for room 1. I have that for every room, plus a source selector for background music for each room, and a master volume, master mute for each room. They are not currently working together. All 4 rooms are separate. Okay. Here's the rules. When I combine 2 rooms, if I combine rooms 1 and 2, if the faders don't match, what happens? They move to the value of the lowest fader. If the mutes don't match, if even one of them is muted, they all mute. It's a safety feature. When you combine rooms, the auto mixer or the room combiner is never going to turn up your volume. It's never going to turn on your signal. So it can't blow things up by accident. If you want to blow them up on purpose, party on. But it won't happen by accident. So if you watch, rooms 1 and 2, when I combine them, the mutes are all going to turn on, and this volume right here is going to jump down to match this one. And this one jumped down to match that one. If I combine room 3 into that, these 2 volumes will both jump down to match room 3 right here, and room 3's master will jump down to match those 2. So it's not a question of everybody matching the new guy or the new guy matching everybody else. In this case, the new guy has the lowest volume for the source, but the new guy has the highest volume for the measure, so we'll change both of them to make it stay safe. Now, that's just one way to control a room combiner. Because, oh wait, operate mode, get out of there. Because if I go over here to the properties for the room combining processing object, I'm on this object now, and I click button to edit as instructed, there's my 4 rooms. Okay, well, it's not actually 4 rooms in my facility, it's 6 rooms. Have a nice day. So let's delete those. Right click and add a grid of rooms. 3 by 3. 1, 2, 3, 4, 5, 6. Don't need those. You have to add a grid bigger than what you need because they don't have all the thousands of possibilities in there. You cannot select a bunch of things and then move them all on the page. You have to move things one at a time. Kind of a bummer, but that's life. Where they appear on this screen affects where they appear on the default control panel later. So we're going to lay this screen out very carefully. For instance, in my facility, room number 6 is actually a full-length room at the end of the hallway that sits next to rooms 3 and 5. Rooms 2 and 4 are right here, and room 1 is also a full-length room at the other end of the hallway. On my control panel, that's actually reflected on the control panel. How cool is that? That's about a 3 on the 1 to 10 scale. 3 or 4 maybe. That's kind of cool. You know, it's not a make or break, but it's kind of neat. But it gets better. Check this out. Let's go back to that same configuration page because I showed you the difficult way to control room combining. The easy way to control room combining is by using partitions. If let's say that here. Partitions can be defined, or use the shift key with the left mouse button to select a pair of rooms, then right-click to define room partitions. That method is stinky. Partitions can also be defined by double-clicking a first room and then clicking a second room. Much simpler. Double-click, click. There's now a partition between those rooms, like an air wall, you know, a movable wall. Right? Double-click, click. Double-click, click. I go through real quick here. Oops. If you double-click on the words, it wants you to rename the room. I can go through real quick here and define all of my Control Z doesn't work either. All of my air walls, all my partitions. And that's important because those become actual buttons on the control panel. Cool, huh? I know. So we can come over here. Let's grab all this stuff. Put it over here, we can see it. There we go. So I want you to watch this happening. Guess we should have brought this stuff over too, to be fair. Now I can do a couple things here. Whoa. Apparently, one of the things I can't do is see custom panel number 2. Thank you. I can do a couple of things here. These partitions are all buttons now. And I can hit these buttons right on the control panel, or I can hit them with RS-232 commands, or I can tie them to control ports in the back of the device and have the air walls hit them for me. They've got those sensors you put up there to detect whether the wall is open or closed. You know, the contact rollerball ones that always fail after 6 weeks. Or better yet, the infrared sensor ones that last a good 9 months before you get to the service call. Yeah, those. Yeah, I'm all about generating service calls here, right? So, or you can tie them to a button. I could have one of the panel manufacturers make me up. Imagine a custom wall panel. Where's the frame? Where's the frame? Just so we know that we're all talking about the same thing. I'm talking about a custom wall panel which contains only the things that are inside this frame. Okay? Have this printed on the panel, and have them put a button here, 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 and here. Just little push buttons, latching buttons. They could be flips, they could be pushes, whatever. And when the staff wants to combine room 1 and room 2, they just go over here and push the button. 1 and 2 are combined. They want to combine 4 and 5, they come over here and push that button. 4 and 5 are combined. They want to change it so that 1, 2, 4, and 5 are all one big room, push the button. Now they're all one big room. Notice they went to the same combine. Now if I change the background music source to one of them, they all change. If I take room 5 out of the mix, it goes back to being independent. If I take room 5 and add it to room 6, now I can use it for a different event. Very, very cool, intelligent room combining. Just by clicking on those partitions, or by having the air walls do it for you. The room combine module is pretty darn neat. There's it's frantic and annoying and just almost mind-numbing at the time to be late with a product when you're going, man, our competitors all have room combine modules and we don't have one. It makes you want to bang your head against the table. But, by the same token, it also gives you a chance to look at theirs and go, okay, now that's really cool, and that's really cool, and that's really dumb. Let's not do that, but that's really cool. All right, let's steal all the cool stuff and put it all into one big object. Pretty much what we did. Took the coolest parts of everybody out there's room combiners and put them into one big object. Any question on how the room combiner works? It's kind of a complex object, but it's worth it. It's 5 minutes after the hour, so if we had actually gotten our stuff started on time, we would have been able to finish on time, but I was late getting the class started. I apologize for that. I hope you guys aren't too goofed up by being 5 minutes late here. No questions from anybody? Alright. Well, I hope that you learned something today. If not, I hope you enjoyed yourself and got to goof off instead of working for a couple hours. And I hope I'll see you guys all in future classes. If you have questions, send me an email. I'll be happy to answer them. No problem. Thanks. See you guys.